Okay, 6.1.3 legs of a right triangle are the geometric mean of the hypotenuse and the piece closest to that leg. Okay, so this is where we're going to talk about the medium triangle being similar to the very large triangle and the small triangle being similar to the very large. Okay, so different than the previous screencast. And in this case, let's try to do one and then the other. Okay, so let's establish the fact that, like for medium, let's see. So we've got this triangle over here, medium, right, will be similar to the large red triangle. And we can see that they share angle x, they both have right angles, and they both share 90 minus x. So this 90 minus x is here, and it's way down here. In your brain, you can see that what you need to do is to take the medium triangle, peel it up, flip it over on top of itself, and then you'll end up with the 90 minus x being concurrent with this one down here. So it takes a little bit of a brain aerobic to get to that point, even though it's easy to see that x is congruent to itself over here. So let's just take a moment and set up the two triangles that are congruent. So I'm going to say that triangle BCE, that's the medium triangle, is similar to, now the hardest thing is to match everything up. So BCE, I chose to make E the last one. That's the right angle. The right angle in the large triangle is B. So I'm going to put B last. The first angle, B, in the medium triangle is the 90 minus x angle, and so that corresponds to D. And C, C is common to both. You may have to take some time to see this one. This is a little bit difficult. Now from this, though, we get some very nice ratios and proportions. So let's be careful here. CE, right, which is the leg of the medium that goes from the 90 to the x, will correspond to this one on the large. So CE, hopefully you see that, CE relates to CB the same way that, now I've got to be careful, the same way that the hypotenuse of the medium, which is right here, right? So BC or CB is the hypotenuse of the medium, and the hypotenuse of the large, I don't know why it does that, the hypotenuse of the large is right here. So C, let's finish this one up, is to DC. Right? You can see here that CB, when I cross multiply, CB squared is equal to CE times DC, and therefore CB is equal to the square root of CE times DC. Now that matches almost perfectly with this one, and you can see that I've just not kept similar structure, but these are the same length. Okay, so that proves the first one. Might be helpful just to say a little bit about the second one. Let's try to see if we can show that one. Now we're going to talk about the small triangle being similar to the large. So in the small triangle, B, this angle up here, relates to the C angle in the large. The 90 over here in the small is E. The 90 in the large is B. And the 90 minus x in the small, ooh, they share that. So D and D, those match up. Okay, and we can do the same thing. Let's do it a little bit backwards maybe. We'll do hypotenuse is to hypotenuse. So BD is to DC. And let's be careful here. The side opposite the x is DE. And the side opposite the x in the large triangle is BD. So when we cross multiply, BD squared is equal to DC times DE. And hopefully I've chosen the right things here. BD is equal to the square root of DC times DE. I need to check that this is matching right here, and I think it does. And I've just switched up DE and DC. Looks fine. Okay, everything else looks fine. Hopefully that makes sense. We are dealing with medium, similar to large, and then we are dealing with small, similar to large.